Well, our derivatives, are fine for sine and cosine, but we also have a few other functions to contend with here. One of them being tangent of x, another being cotangent of x, secant of x, and cosecant of x. So we might ask ourselves, what do we do to find those derivatives? And what we're going to do is this. We're going to, rather than try and go through and use our slope or use our limit definition, this time we can make it a little easier on ourselves by just going back to our rules here for our sine and cosine. So the derivative with respect to x of the sine of x we know to be cosine of x. And we also know that when we take the derivative with respect to x of cosine of x, we're going to get the negative of the sine of x. So how is that useful here? Well, let's take a look at our first function here, tangent of x. We can say that if we're interested in finding the derivative of tangent of x, the way to treat this from the perspective of sine and cosine is by using a ratio of sine of x over cosine of x, which means, you guessed it, our 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 quotient rule. You remember the quotient rule? Hold on, let me write up my quotient rule. My quotient rule says that if I take the derivative with respect to x of u over v, where u and v are both differentiable function of x, then we get v u prime minus u v prime over v squared. Or you remember the little tune, low, 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 d high minus high, d low. There we go. It's our sine and cosine of x in the high and low positions right here for our numerator and denominator. So let's work this one out. By our quotient rule, we're going to have cosine of x times the derivative of sine of x, which is cosine of x, minus sine of x times the derivative of cosine of x, which is negative sine of x. And all of that is divided by the square of the cosine of x. So in this formula, we end up with cosine squared x plus sine squared x divided by the square of the cosine of x. And now I'm sure you're probably pretty glad that you remember, at least I hope you remember, our Pythagorean identity, which states that we now have 1 over the square of the cosine of x, which is another way of stating that if you take the derivative with respect to x of the tangent of x, then you're going to get, as its derivative, the square of the secant of x. That's pretty cool. We just transform one to the other. Is that the way that it works? Well, let's try another right here. I'd be interested, now that I'm here, I've got to see what's going to happen to the secant of x. So I guess we're going to try the same trick, right? Let's see what we can do. Let's take the derivative with respect to x of secant of x and see what happens when we treat this as the derivative with respect to x of 1 over the cosine of x. All right, by this rule right here, by our quotient rule, that means we're going to have the denominator times the derivative of the numerator. Well, that's 0. Oh, wait, this is different. Minus the cosine, minus, well, not cosine of x. Let's try that again, right? Because we need to change that. Minus 1 times the derivative of cosine of x, which is negative sine of x, all divided by the square of the cosine of x, which is interesting because now it looks like we get, well, just plain old sine of x over cosine squared x. This is a little bit too complicated. Let's see what we can do here about getting rid of that fraction. Let's do a little bit of a trig rewriting right here. This is going to be sine of x over cosine of x, which is tangent of x. So it looks like we're getting tangent of x back. Will this make it kind of like what we did the last time? Times 1 over cosine of x. Well, alas, no. That means that it's going to be tangent of x times the secant of x. Ooh. All right, interesting, interesting. So we've got secant of x covered, and we've got tangent of x covered. Okay, for homework, you're going to verify the following. For homework, verify that you indeed get the derivative with respect to x of the cotangent of x equal to the negative of the square of cosecant of x, and that likewise the derivative with respect to x of the cosecant of x will be equal to the negative of the cosecant of x times the cotangent of x. All right. Verify these for homework. I expect it as written work. I'll see you in class.